Hey guys, my name is Chris and welcome to the 7th episode of our tutorial series. In this episode we're going to learn about shaders. Shaders are a bit more of an advanced topic, but I'm going to teach you the basics of what they are and a way to create them that's a little bit more user-friendly. Here's an example of what a shader can do. We'll be creating this shader in our episode today, and we'll also be hooking it up with code so that when our character hits an enemy, they'll be flashing red. So shaders can be a pretty confusing topic, so I want to explain them in their simplest terms, and I'll definitely show you some examples. So basically what shaders are coded programs that tell the computer how you want a 3D model to look like in your game. So they do that by manipulating pixels or vertexes on your 3D models. Most of the time, or not most of the time, but oftentimes they're used to calculate lighting information on your models, but can definitely be used to create special effects. So even if you aren't customizing your own shaders, whenever you import anything into Unity or any game engine, it'll automatically apply that game engine's standard shader. So anytime you ever see something in a video game, it's because it has a shader on it. If it didn't have a shader on it, it wouldn't be able to be rendered at all. So in our first example here, we have 3 different types of shading. So this is manipulating lighting information. The first one is what we expect in real life with a normal fall off of shadows and highlights. And the second and third ones are what we call cell shading or tune shading, in which the lighting information is sort of clamped into these 4 or 7 different sections. You could have as many different sections as you want. And we'll show an example here in Legend of Zelda Breath of the Wild. They've created a similar sort of two-tone, we'd call it two-tone or two-band shading, since there's only 2 solid colors you can see here. Although there's a lot more complexity into this shader, but that's sort of the basic idea. But yeah, it definitely gives your characters a unique look and makes them stand out to the background. As you can see, the shader that they're using on the background stuff is definitely different, so their characters really pop. On the other end of the spectrum, shaders can be used to create different special effects. So all of these here are different pixel shaders. So we have the first one on the left is sort of your standard shader, what you would expect. And then we have even ones sort of like an outlining shader here. The second one, it's called Fernelling. It's called the Fernelling effect. We have some hologram shaders over here. We even have on the far end, we have a dissolve shader. So you can see that part of his body is completely translucent, so you don't see it. And then the second part of the bottom half is being rendered. Same as over here, they have sort of chipping away at the body. So those are some things you could do with shaders. This one here, they have sort of like a snow fall off on the character to make it look like he's been snowed on. Different solid color shading here, cutaway shader, gradient shader, a bunch of different things. Shaders, really you can do anything and everything with them. But these are pixel shaders. So then we're going to move on to vertex shaders, which we won't be showing in this episode, but I'll explain to you what they are. So the other type of shaders are called vertex shaders. They aren't used as often, but what they do is they actually allow you to manipulate the vertices on your 3D model. So in this example here, we have our basic shader here, and then our vertex shader here is manipulating the vertexes and actually sort of pulling them outwards. So you can basically manipulate your model rather than just visually, actually like almost physically. But let's move into Unity and show you how to make a pixel shader. So we're here in Unity now. I've created a fresh project and just imported this fan model that's broken up into 3 different sections. So what you may already be familiar with in Unity is something called materials, which we've been using in this project so far. So if I right click the project window, go to create a material, I'm just going to call it fan, just change it to red or something, and I'm just going to apply it to model here really quick. So if we take a closer look to this material, we can see something called shader right here. There's a little drop down menu with the title shader on it. So this is using Unity's standard shader. As I was explaining earlier, every time you create a material in Unity, it automatically uses Unity's standard shader. If you click on this drop down menu, you can see the list of all the different types of shaders that come with Unity. What we're going to do is we're going to make our own shader, and it's going to show up in this list that we can apply to any material. So Unity Standard Shader allows you to put in different maps like albedo, metallic, normal. Here we have some here. I'll show off what that looks like. We have our albedo, our normal, and our metallic maps. So Unity Standard Shader has allowed you to sort of affect these different channels. So if I were to actually delete this material, you'll see that our model turns pink. Very ugly, bright pink. So technically these models are completely missing a material. There's no material and therefore no shader on this object. So as I said earlier, if an object does not have a shader on it, it will not be able to be rendered in game. Unity, to make sure, so it would pretty much become invisible at that point. Unity has made sure to apply this really ugly, bright pink to any object that is missing a shader, so that it's easier for you to tell if something's missing, because obviously this is not something you want in your game. So it's easy to spot out, and just kind of shows you, hey, this is missing a shader, you have to apply one. So to make your own shader, all you have to do is right click the project window, create, and instead of going down to material, we're going to go all the way up here to shader. We're going to create a standard surface shader. So there's a few other types, but we're only going to be explaining this one. This is sort of your basic shader, surface shader. Let's just call it fan shader. So this is what a shader looks like. It's rainbow colored with a big S in the middle of it. And now we can apply that to our material. Let's recreate that material really quickly. And you can see here it's using the standard shader. If we click down this menu, we can go to custom. So we've made a custom shader, and now our fan shader shows up there. So by default, it allows you to customize color, put in an albedo map, and we can apply that. Oh, let's put this back to white. But other than that, we haven't customized anything else. This is just kind of what comes basic with it. But now we're going to show how to customize it. So traditionally, shaders are created through specific shader code, and these can get quite complex. As you can see, this is the Unity standard shader, and it's around 12,000 lines of code. So pretty big. Even our fan shader that we just created is still about 6,000 lines. Just basic, we didn't even do anything to it. So shader code can get pretty complex, but in the last few years, there have surfaced new ways to create shaders through something called node-based tools. So there's a few on the market. One I highly suggest is Amplify Shader Editor, which is around $60 to $80 Canadian. But today we're going to be using a free tool that's created by Unity themselves called Pbr Graph. So to download Pbr Graph in Unity, you just go up to Window, open up your package manager. So these are all the different packages that Unity themselves have sort of integrated into their software. So make sure that you click up here under packages, click all packages. So you're not just looking at the ones in your project, you're looking at all packages. And we're going to scroll down to where it says Pbr Graph, and just quickly hit install. So Pbr Graph has just finished installing, but before we can go into making a shader, we have to install something called the lightweight render pipeline. So Unity has introduced these things called pipelines into their workflow, and they've created two different presets. They've created the lightweight render pipeline and the high definition render pipeline. Pbr Graph requires that you use one of the two, or you create your own pipeline. It does not work with the default 3D pipeline. So if you're going to be using Pbr Graph, you have to convert your project to the lightweight render pipeline or the high definition render pipeline. We've already been using the lightweight render pipeline in the rest of this tutorial series, so if you've been following from the beginning, I'm going to show you how to download it right now and convert your project to lightweight. You can start the project in lightweight. When you create the project, you can set it to using one of those pipelines, but if you haven't done that, which I would think most people haven't, we're going to show how to get started with that if you've already created your project. So we're just going to go to lightweight render pipeline and click install here. Okay, so now that we have lightweight render pipeline installed, I'm going to show you how to set this up. So click out of the package manager. First thing you want to do is right click your project window, go to create, rendering, lightweight render pipeline, pipeline asset. So you just hit default, You can name it whatever you want, but this is basically the pipeline asset, and we have to hook that up. So go up to edit, go up to project settings, and in the graphics tab you'll see that it says scriptable render pipeline settings, and it's not using one right now, so we're gonna set it to use the lightweight one that we had just created. So our project has changed a little bit. As you can see, our material now was using the standard shader, which is not compatible with the lightweight render pipeline. So pretty much when you do this, all of your materials will then become unusable, but very easily, if you go up to edit, render pipeline, upgrade project materials to lightweight render pipeline, this will take all of your project materials and upgrade them very quickly, upgrade them to using the lightweight render pipeline lit shader, which is basically Unity's standard shader for the lightweight render pipeline. So as you can see, it's okay if you've already been creating everything like halfway through your game in the 3D, the default pipeline. You can easily switch over to the lightweight render pipeline, and with edit, render pipeline, upgrade all your project materials at the same time to the lightweight shader. So now we have access to creating different graphs. As you can see here, at first we only had these 4 options, which allow us to make shaders through code. Now we have these 3 different options that allow us to create different graphs through shader graph. So we're going to be creating a Pbr graph. We're only going to be explaining this one. This is also your sort of basic standard type of shader that you'd most likely be using. So we'll just call this, just call it test for now. And as you can see, it looks exactly the same as the fan shader. It's the same sort of style, but it now has this option of open shader editor. As you can see, this one does not, because this is sort of a coded one, while this one is a graph. So if we click open that, oh, it just opened on my other screen. I'm going to bring it over though. This is what shader graph looks like. So if I just make this full screen here, this is practically equivalent to what we saw in when I showed you the shader code. So it's very user friendly and it's all visual. There's no coding involved. There is some coding logic that you'll have to maybe understand when you're creating shaders, but no code. It's all through these things called nodes. So really quickly, I've just cleaned this up a little bit, but I'm gonna set our material here over to our fan shader. So I'm gonna go down to shader graphs. We're not gonna go to custom, that's for the coded shaders. We're gonna go over to shader graphs and we're gonna click on our test graph. I'm just gonna delete this fan shader. We don't need that shader anymore. So pretty ugly right now, but as you can see, there's literally nothing here. We haven't applied any sort of things that you can manipulate in the editor. It's completely barren, but we're gonna change that. So back into our shader graph, I'm just gonna explain sort of these 3 windows here. This is sort of your basic shader graph tutorial. Let's start here in the bottom. So this is just your preview window. You can minimize it. There we go. This just shows you what your shader output will look like as you're creating it, sort of in real time. You can also right click, change it to different shapes if you want. If you want if your shader is supposed to be played on a quad, plane, or you can even set up a custom mesh. So I could even do our fan body here. And now we can see what the shader will look like sort of in real time on our actual model, which is really cool. So the next window I want to explain here is called the Pbr Master Window. So this is basically our shader in a nutshell. This is our shader. So it contains all of the different channels that we can manipulate. So for example, in our albedo here, let's just quickly change it to red. You can see our shader is now red, and if we save the asset top left, we have a red shader. We have a red material. So what we can do is we can right click anywhere and create nodes, and we can use these nodes to sort of manipulate all these different channels in our shader. So let's just quickly create a color node, and now if I plug that into my albedo, now we can update it through the node. What makes this even better is when we pull in this third window. So this is our parameters window. So this allows us to edit our shader in the editor. So right now you can see that we have this color node, but you know, when I'm in the editor, if I have this closed, or if I'm somebody else working on the project, I can't edit the shader at all. So what we can do here is click this little plus sign, and we have different values, parameters that we can expose to the editor. It's called exposing to the editor. So we're going to create a color parameter. Let's just call it color. We're going to make sure that exposed is turned on. Let me just make this bigger. Exposed is turned on. We're going to set the default to red so we understand what's going on. Actually, I'm going to set it to blue. And we have a default mode, and I'm going to save the asset. Now I'm going to drag this color parameter into our window. Delete this one. We don't need this one anymore. And if I drag this to our Pbr Master Node, you can see that it's applying our blue. If I save the asset now and go into the editor, you can see that we have this parameter now that's exposed in the editor. So even if I close Shader Graph, don't even see it anymore, I now can affect the color of our model through the editor. So let's just reopen our shader really quickly. So these are the three basics of creating a shader. We have our parameters that we can expose to the editor. We have our nodes that we create and plug into our channels into our Pbr Master Node, which is the skeleton of our shader, and we can all preview all of those things through our preview window. So now we're going to get into creating a shader for our character that you saw at the beginning of the episode with the flashing red, and then we're going to explain how to code it so that when the character gets hit by an enemy, it'll activate that flashing effect. So we're back in our tutorial game, and you can see that we have our player here. If we click over to his base, we can see that his materials are using the lightweight render pipeline lit material. As you can see, the standard lightweight shader. And also that his model is broken up into three parts. So we have the body, we have sort of the connector pieces, the sort of like the arms and legs, and we also have the sort of translucent glass piece in the middle. So as you can see, I've already created these shaders, but I'm going to show you how to do that from scratch. So we're going to right click the project window, go to create shader Pbr Graph. I'm just going to call it tutorial shader 1. And all you have to do is double click. Open up on my other screen, but I'm going to drag that over. So now we have our shader, which is what we saw earlier. I'm going to leave the preview as a sphere for now. We don't need it to be our model. So if you remember when we looked at Unity's standard shader, they had a bunch of different maps that you could put in, like your albedo, your metallic, your normal. But right now our shader doesn't do that at all, doesn't do anything. So let's just quickly create a material here and set that up. So I'm just gonna write character 1. Go over to our shader, make sure we set it to our new shader. Shader graphs, we want to do tutorial shader 1. So we don't have anything, we haven't exposed anything, we haven't created anything. So we want to do some of those basic things that the standard shader does. So if you look on our character, we have a bunch of different maps. If I go to its body, we have all these different maps. We have albedo, we have a metallic, we have a normal, we have an emission map. So we need to expose our shader to do those sort of similar different things. We have the albedo that can be affected by color. We have an emission that can be affected by color as well. So first things first, before we make that really cool red flashing effect, we have to make our shader allow for simple maps, just like albedo, normal, just like the regular standard shader. So right now we're going to quickly replicate Unity standard shader. So to allow for that input of different maps into our shader, we want to press spacebar, or you can right click and press create node. And we want to look for something called a texture 2D or a sample texture 2D. Now this node will allow us to plug into any of these different outputs on our shader. So let's stick with the albedo for now. And it allows us to apply a map. So if I click on this little button here, I can apply any sort of albedo texture that we want. Let's say this one's for our character. And you can see that it shows up on our sphere here. But we want to expose that property to allow you to customize it in the editor with whatever map you want. We want to make it so that this shader can be used sort of on multiple different characters if we want, or multiple different 3D models, because right now we have it hard-coded, whereas it'll always use this texture. So if we go up to our parameters, it's called the blackboard. This is what the window's called. Also, if you don't see this blackboard here, you can just click on the top right blackboard. It might be checked off also for the preview. If you ever don't see one of these windows, make sure those are checked on. But we click this little plus sign and we want to do a texture 2D. So now this will allow us to expose any sort of textures we want. Let's start with albedo. Make sure expose is checked. We're going to set the default to nothing right now because we want to be able to customize it to whatever we want. So let's drag in our albedo texture 2D and just plug that straight into our texture. Now if we save the asset, let's switch over our character to be using our shader graph, tutorial shader. So as you can see, all we have applied right now is that albedo texture. So if we just click search for the proper one, and there we go. Now we have an albedo texture just like the regular standard lightweight render pipeline lit texture. They call it base map, but it's practically albedo. Albedo is just color information. So we have our albedo map, but as you can see here, they allow you to change the different color of it, or to sort of multiply different color information into that map. So let's do that next. So we have our albedo here, our albedo map texture, but we want to be able to multiply some color into that. So sort of add some color information to that. So very easily create a color node. And if we ever want two nodes to sort of intermingle with each other, we can use a multiply node. So this multiply node takes in 2 inputs and outputs 1. So the multiply we can put into albedo, and we can put in our 2 inputs, our albedo map and our color, to now put these 2 nodes together. And so if I click this to red, save asset, we now have our albedo that's colored red, but we haven't had that exposed. So let's do this the proper way and expose this so we can change it in the editor. So we're gonna press the plus sign, press color. I'm gonna write albedo color. Make sure it's exposed. Default I'm gonna set to white because the default for albedo should always be white. Plug that in properly to the multiply. Doesn't look like much is happening here, but when we go into Unity, you can see that we now have albedo color that we can now affect. So the Unity standard shader has a bunch of these different maps that they use for each one of these outputs. So they have an albedo map, a normal map, an emission map, metallic map. So we're going to easily do that really quickly by just simply copying and pasting. So we're actually only going to copy and paste the sample texture 2D node, Control C, Control V. We don't want this to use a default texture. Okay, so we have our different maps here that we want to affect. As you can see, we left smoothness because smoothness is usually affected through a float value or simply a slider. Usually 3D softwares don't use a smoothness map or what's called a roughness map, but if you want a roughness map, you can simply do the same thing and plug in another sample texture into smoothness. And now we have to make all of our parameters available to be exposed in the editor. So I'm going to do that really quickly. Okay, so we have all of our parameters here. Now we're going to simply plug them all in. So normal map, plug it into normal. This one is our emission map. Next is metallic. And then ambient occlusion. So most of these work just straight out of the gate, but the one that we have to change is the normal map. As you can see, there's different modes. Specifically for the normal map, it needs to be told that it is a normal map because it has to do some specific calculations. So as long as we set this to bump, then it'll work just fine. So now we can save our asset and go over to our editor. Things are looking a little out of whack right now, but as you can see, we have all of those textures now exposed, so we can easily go to our normal, our metallic. This is our metallic. We don't have an ambient occlusion map for this specific model, but if you did, that's where you would plug it in. And our emission. So two more little things we want to just quickly do is add emission color actually. So now we can sort of multiply just like we did with the albedo, an emission color into our emission. So where's our emission? There it is. So let's multiply those two together again with the multiply node. And we're going to replace that input. We're going to default this to white actually because we're using an emission map. We automatically want that to be fully white because it's sort of like a mask. Make sure that's exposed, save the asset. Now our emission is coming through. If I put that to black, you can see the emission is not coming through. And then also we just want to do smoothness. So like I said earlier, smoothness is usually just a vector value. So we're going to call this smoothness slider. So sorry, that was a vector 1 by the way. And then we're going to change the mode to slider because we want to be able to go from two different values. So we're going to go from minimum 0 to a maximum 1, and we're going to default to 1 because I would like the smoothness to be completely 1. Save the asset. You see smoothness slider we now have. Oops. Just a bit of control over that smoothness value. I lied. We didn't plug it in. There we go. Now we have control over that smoothness value. There we go. You can see it a bit on the edges. So another thing I forgot to mention for the normal map is we had already set it to be a bump, but another thing we want to do is set the type here to normal. So to tell the actual sample texture 2D that we're working with a normal right now. So that'll make it properly show in the world. I was wondering why there was getting some weird artifacting going, but as long as you set that to normal, it should behave the way you expect it to. So these are sort of the basics that you want for replicating almost Unity standard shader. It has all of the maps that you would want to expose, and you can see even here if we go back to the lightweight render pipeline lit, it practically looks the same. So I'm just going to set that back to our tutorial shader. You see there's a bit difference in the lighting calculations, but basically it's doing what we want it to. So now we're going to move on to creating that red flashing Fernell effect. So for this effect, I'm just going to quickly move our shader over here just so that it allows us to see what we're working with a little better. I'm actually just going to close the hierarchy window. We don't need it right now. And I'm going to close this preview. We don't need the preview since we have our preview right here. Let's double check that we're using our proper tutorial shader, and let's get started. So I'm just going to quickly clean this up a little bit so that we have room and I can properly explain what's going on here. So all of our maps, we can take them and we're just going to move them. We're just going to move them up here. But the one map that we want to affect right now, that we're going to put more work on it into, is our emission map. So we're going to bring these ones back down. And we're going to focus on these ones for a couple minutes. I'm just going to disconnect this as well for now, because we want to add some things to it. So the node in question here that we're going to be focusing on is something called a Fernell node. So it's typed F-R-E-S-N-E-L. It's called the Fernell effect. So what this does is it's basically sort of like a rim lighting, and it can make for really cool effects. It's used quite often in games, and we're gonna make it look. We're gonna change the color to red. We're gonna animate it to flash in and out, and this will be plugged into our emission map. So right now, if I just quickly multiply this with a color node, and if we plug that into our emission, I can show off what this looks like. Change that to red. Make sure to save our asset. So you can see here it already has basically what we want it to look like. So even just doing something like that can get you sort of already what you want. But you can see that our light is turned off now because our map is not plugged in anymore. So we're gonna have to do some changes to this. Also, we want the value of the power. So how bright it is, how strong it is. We want to be able to change that value in and out. And we're going to be doing that through code, but we have to set it up to allow for that. So first things first is I want to actually get this texture back in here. So the way we do that, let me just disconnect this now. We are going to actually add these two multiplies together. So where multiply sort of blends two nodes together, the add node adds two on top of each other, just as the name suggests. So when you're multiplying so let's say a color with a texture, you are infusing those two nodes together. But when you're adding, you are technically adding this group of nodes with this group of nodes on top of each other. So if we put this add node into our emission, save the asset, we are now back with our Fernell effect and our emission map added on top of each other. So we're going to want to affect this color. We don't want to just have it hard-coded. So we're going to make another color parameter, call it Fernell color. And we're actually going to change the mode to HDR. So HDR is a wider range of colors, and it allows you to affect the intensity to make it bright, to make it really pop. So let's set the default to red. Let's bump that intensity up a little bit. And we're going to replace this color node with our new parameter. Make sure it's exposed, save the asset. And if I go into my inspector and I click on this Fernell color, we can really bump up the intensity to some absurd numbers. Let's just keep it at 1. Okay, back to our shader. So if we go over to our Fernell effect, you can see that we have one of the inputs is called power. And if we affect this, we can basically see that it's changing how drastic the effect is. Whereas if you go all the way up to something like 10, it's basically unnoticeable. And if you go into the negative numbers, then it gets really powerful. Personally, I don't like how negative numbers make it more powerful and positive numbers make it less powerful. So I'm just going to be explaining something really quickly called a remap node here, where basically it allows you to remap different ranges of values that you're working with. So if you plug that into the power node, you can see that if we set this back to 1, you can see it's basically what we had before. But right now it's saying where -1 is on one end of the spectrum and 1 is on the other end of the spectrum. If we switch those two ranges, it now flips. So now when we have X values, it's very strong, and when we have positive values, it's very strong, and when we have negative values, it's getting weaker. I want to flip this range. So right now when we go to -10, it's weak, but it's still nice. And when we go to 0, it's a little too strong. I'm just going to make this so that when we go from 10 to -1, and when we go from -1 to 10, we now have it so that if we go to 0, if we set this value to 0, it's very light, sorry. But then if we go all the way up to 10, we now have that nice fall off. And it makes sense sort of in our heads, right? We go from 0 to 10, it gets stronger. So I'm just gonna set this to 1. But now we want to be able to affect this slider through the editor, right? So let's create another vector one. Call this Fernell slider. Whoops, spelled that wrong. Fernell slider. We want the range to be, let's set a slider. Now we want the range to be from 0 to 10, right? Because that's what we set our remap. 10 is a little high actually. If we set this to 10, you see that 10 is just completely solid. So I'm gonna set it to about 8. 8 was pretty good, right? 8, yeah, 8 was good. And the default I'll just set to, I'll set it to 0, it's default. Now we plug in this slider through our remap node. The value is getting remapped and then brought over to the Fernell. And if we save our asset, we can see that the Fernell is very weak. And now we have this slider to set it all the way up to 8. So as you can see here, when the value is set to 0, which is the lowest our slider can get to, we still see the effect, but we don't want that to happen. As we're playing the game, we want it to be, we don't want to see this effect at all. So in order to do that, we're going to multiply these nodes, this Fernell effect node. We're going to disconnect this right now. We still have our texture, we're okay, we're going to put that down for now. We're going to multiply this output, so our multiply, with another vector that practically goes from 0 to 1. And what it'll say is, if this value is set to 0, our effect will be turned off. And when it's set to 1, our effect will be completely set to max at 8. So we're going to call this our flash damage vector. And it's going to be a slider. Sorry, not an integer, a slider from 0 to 1. Plug this in and we're going to multiply it with this output. So as you can see, these nodes come together to create this output. Or now we're going to multiply it. Oops, I'll put it at the top. Multiply it with this value. So now you can see in our little output, right now the default's set to 1. And there's nothing showing, but if I set it to, sorry, the default is set to 0 and nothing showing, but if I set it to 1, and then we set the slider as default to 8, we now see our effect playing. So let me just show that one more time. Default 0, it's off. 1, it's on. So this value is going to be the one that we're going to give to our coders, and they are going to reference in code. So as you can see here in our parameters, we have this thing called a reference. So right now, if the coders wanted to call this value in their code, they'd have to call it vector1 underscore e for f8. So that's pretty annoying. So we can actually rename this to anything we want. So let's call it underscore flash. Actually, I won't put the underscore. I'm just going to show you what it looks like. I'm going to call it flash damage vector and press enter, and it automatically puts an underscore. I believe they did that because it just makes it so that you don't accidentally call the same name. So it's sort of unique in its own way. So now we can tell the coders, hey, we have this reference called underscore flash damage vector, and that is the one that we want you to animate from 0 to 1. Very simple. And let's make sure that we reconnect everything back to our add node. And save our asset. And now we can see that the Fernelling effect is gone. I'm just going to double click on our material. And we now have our Fernell slider and our Fernell damage vector. So if I turn that all the way up, let's make sure that our Fernell slider is maxed out. So if I turn the flash damage vector up, we now see that we can animate only this value, and it'll go from nothing to completely lit. So I'm going to pass it over to my friend Nagusha, and she is going to teach us how to code this value to go from 0 to 1, specifically when we get hit by an enemy.
So, welcome back to the programming corner, and this will be the last time you'll be with me. This is the last major thing we gotta code, and so let's get to it. So what we're doing is we're gonna make that shader, the flashing kind of effect, and then we'll be off. The first thing we're gonna add is a serialized private float to see how long the player is invulnerable for. Now we're gonna add a list of materials. These are the materials that have that shader on them so that they'll make the flashing color, and we're gonna declare it as well. So at the bottom of awake, we're gonna grab all the materials from the game object, children, and then for each of those materials, we're gonna check if they have the property flash damage vector, and if they do, then we're gonna add them to the materials for damage list. So now we're gonna go into the invincibility function, and this is actually a coroutine, and a coroutine is a function that is capable of waiting and timing its process, so it's good to have the invincibility mode for a set period of time. So in the coroutine, we're gonna add the float start time, and that's just gonna be the current time when the coroutine started. We're gonna set the can take damage to false, and we're gonna make a value variable and set it to -1. So while the time.time, so that is the current time minus the start time, all of that is less than the invulnerability seconds, we're going to check for every material in the materials for damage and set their float value for the flash damage vector to be mathf.clamp01 and pass in that value. How this value is going to change is we're going to flip it every time by using value times equals -1. So what that's doing is it's setting it to -1 and then +1 and back and forth. And we're just going to yield return wait for seconds 0.1f. So it flips every 10th of a second. Now that the invulnerability seconds ran out, we gotta take all the material on the player and turn them back to normal. So what we're gonna do is we're gonna set the flash damage vector to 0, and then we're gonna take damage to equal true so you can take more damage, and then yield return null so that the coroutine ends. The last thing we need to do in the take damage function is check if the player's not dying. Then we call the start coroutine of invincibility. So in previous videos, we actually made a mistake in the check for death, and we forgot to actually respawn the player to a checkpoint. So in here, if the current health is less than or equal to 0, right before returning true, we want to do checkpoint tracker.respawn, and that will fix any mistakes that you could have had by the character getting negative health and not actually respawning.